Okay, so here's the final video I'm going to do. It's review number 2 and 3 together. Alright, so let's get started. So number 1 is x to the negative 4/3 power. To get rid of that negative, we have to rewrite it as a reciprocal. Oops. Isn't that interesting? Alright, so this becomes 1 over x to the 4/3 power. Alright, so these fractions get written in a square root sign, and the denominator is the cubeth root, so that goes outside, and it's x raised to the 4th power, and then 1 over. So this is number 3. We learned that a is equal to the y-intercept. Okay, so this is right here, this a, this y-intercept, so it's somewhere between 0 and 5. So it can't be greater than 5, and it's definitely not less than. It's greater than 0, but the other one's not going to work. It's not greater than 5. It is less than 5, so we're going to leave those two alone for a second. And then we're going to take, I guess we could leave the a greater than 0 too, but then we're looking at it, it's descending, right? So descending means that the b has to be between 0 and 1. So it has to be some kind of decimal. Okay, so it's going to go between 0 and 1, so that b has to be less than 1. So it's all the decimals, 0.999, 0.5, all the way down to 0.0011. So this one's going to be number 4. Okay, b can't be less than 0 because we can't have negatives. All right. To find, this is the general form of a exponential function. So what we can do is we can set up two equations and then solve for the unknowns. So the first one, y is equal to 6, is equal to a b raised to the 4th power. Right. The second equation we can make 0.5 is equal to a b to the 8th power. Now you could flip them around and put the 0.5 on top, and and you'll still get the same value for b. So let's divide these. 6 divided by 0.5 is 12. A's will cancel out. We divide this, and then so this is equal to b raised to the 4 minus 8 power, right? So we subtract exponents when we are divided. So 12 is equal to b to the negative 4th power. So I have to multiply this by the reciprocal to get 1. Right? So this will just give me b on the right side to the 1st power, but I also have to do it to this side. So you take out your little calculator and you do b raised to the 12 raised to the negative 1/4 power. So you put in your calculator b 4 you put in here 4 raised to the negative 1/4 power. All right, you can put it in as a decimal, and you end up with 0.537. So the closest one to that is 3. All right, the undefined logs cannot be 0. They cannot be 0. Or less than 0. So they can't be a 0 number or a negative number. So if you look at this, 2, if you put in 2, it's 2 times 2 minus 3, right? This is 4 minus 3, which is 1. That's okay. This becomes 6 minus 3, which is 3. That's okay. So this one's okay. This one's okay. And this one becomes 14 minus 3. That's okay. But the first choice becomes 2 times 1 minus 3, which is 2 minus 3, which is negative 1. That's not okay. So that would make it undefined, so it can't be part of the domain. All right. The next page. All right. So the first thing we should always do is isolate the exponent, right? So I can move this 3 over. If you had something added to it, you would subtract it. You would undo addition, subtraction, and then undo multiplication and division. All right, so I would divide both of those by 3. Now I have 5 to the 2x power is equal to k over 3. Now, it's interesting to use this base because if we have log base 5 of 5, that's going to become 1. And we can put the exponent in front of the logs, right? Because exponents raised to an exponent means to multiply. So we're going to multiply 2x times log 5 base 5 is equal to log base 5 of k over 3. Okay, this comes out because this is really 1, and 2x times 1 is 2x is equal to log 5k over 3. Now, whatever you do from this point on, you're either adding to the log or putting it in front of the log, because this is the log base 5k over 3 is like represents one number. So let's divide by 2, but we're really going to divide this by 2, and it really becomes 1/2 of log 5 of k over 3, which is number 4. Okay, not too many log problems on the midterm. This one wants to get all the zeros, right, because this is equal to 0. So negative 3x is equal to 0, x is equal to 0, x minus 4 is equal to 0, x is equal to 4, and 5x plus 3 is equal to 0, right? You move the 3 to the other side and then divide by 5. So you subtract 3 and divide by 5, so it becomes negative 3 over 5. So that is choice number 4. Next one. We can get this make this equivalent by completing the square. X squared minus 8x. We're going to leave a little space there with the 2x terms, plus 5. We take this number, which is b, and we do b divided by 2, and then square it. So in this case, it's negative 8 divided by 2 squared, which is negative 4 squared. And this number always comes out to be a positive, so this is positive 16. Now, with parabolas, this number is on the same side, so if we add 16, we have to subtract 16, and that way we wouldn't be ruining any of the laws of algebra, because if we combine the like terms here, we would end up with this original equation. Okay, so now 16 is a perfect square and half of it is 8. So we have this thing called the perfect square trinomial, which factors into this. Y is equal to x. The square root of 16 is 4. Remember, whatever sign this is in front of the middle term or the b term is the sign in our answer. Squared, and then we have 5 minus 16, which is minus 11. So that's number 4. This one says determine the y-intercepts. Y-intercepts occur when x is equal to 0, right? Because it would go through something like this, right? So at this point, x is equal to 0 and y is some number. So y is equal to log 3 of 0 plus 81. So y is equal to log base 3 of 81. And we have that circular thing. This is the base, 3 is the base, y is the exponent, and 81 is the answer. So this becomes 3 raised to the y power is equal to 81. All right, so what number raised, 3 raised to what number is 81? And 3 raised to the 4th power is equal to 81. So y has to equal 4. So when x is 0, y is 4. All right, an inverse problem. So for me, you know, and you have a graph, I mean, you could find the inverse and then, you know, set them equal to each other. Then you'll have a decimal to work with, or you'll have a fraction to work with, which would be 1/3. Not the easiest thing to do. So what I would do is I would graph this. Maybe if it was an even number, it'd be a little easier. Our y-intercept is equal to 8, or negative 8. And our slope is 3 over 1. So we could start at negative 8, go up 3 over 1. Yeah, okay, let me start at negative 8. 1, 2, 3, 4, 5, 6, 7, 8. Up 3 over 1. Up 3 over 1. 3, 1, 2, 3 over 1. 1, 2, 3, 1. 1, 2, 3, 1. 1, 2, 3, 1. So this is the line of y equals 3x minus 8. Okay, now I'm going to take each one of these points. A couple of points that are interesting, right? The y-intercept is 0, negative 8. So the inverse is going to be negative 8 comma 0, which it actually becomes the x-intercept. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8. It's this point here. And really, you know, if you wanted to and do instead of all those points, I mean, you could do it by finding the inverse, switching x and y, and then solving. So this is x plus 8 is equal to 3y. Divide by 3. Divide by 3, divide by 3. So y is equal to 1/3 x plus 8/3. Now 8/3 is hard to find on the x-axis. It's 2 1/2, and you'd have to deal with half ones. But we have this one here. We have the 1 point that's nice. So we can go up 1 over 3. Up 1, 1, 2, 3. Right? And that's with this point here. This is the point 1, 1, 2, 3, 4, 5. This point here is 1, negative 5. So its inverse would be negative 5, 1. Right, which is what this point is. 1, 2, 3, 4, 5, 1. So this point here is that one. Okay, and then you can get the next one is 1, 2, negative 2. So 2, negative 2. So the inverse of that one would be negative 2, comma 2, which is 1, 2, 1, 2. This one here, and again, it follows the slope up 1 over 3. The y-intercept is hard to get, right, because you see the exit goes through here. But the next one is 1, 2, 3, 1. So that has to be the point 1, 1, 2, 3. Okay, the next point is 1, 2, 3, 4, comma 4, right, which the inverse would be 4, 4. And that's what we're looking for, that intersecting point. So we know that it's going to go through here, right through this point here. So it's this point here, which is 4, 4. All right, so the intersection is at 4, comma 4. So that would be our answer. So that's where the graph of the line and its inverse meet. All right. So these three equations and three unknowns, you know, the y's kind of have different, you have y and you have negative y. It's always easy to do those first. You could do them in any order. If we do this as A, this is B, and this is C, the first thing I would do is I would just add A plus B. I'm sorry, A plus C. Just add those two equations. And the y's will cancel out. A plus C. See, the y's have different inverses of each other, their coefficients. One's positive, one's negative one. When we add them, they'll come out to be 0. So this is plus 5z is equal to 13. And when we add these, we get 7x plus 8z, the y's cancel, is equal to 16. Okay, so now I'm going to look at B and C. Let's see, A and C. What do we do? A and C. Then I have looked at A and B because they have A and C. You know, you could do any of them. I'm going to do A and B. But I'm going to have to add, I'm going to have to multiply by negative 3. So I'm going to take negative 3 and multiply it times the A equation. And then I'm going to add the B equation. So I'm going to multiply this one by negative 3. So this is my second step. So I have negative 6 minus 3y minus 9z is equal to negative 3 times 3 is negative 9. Okay, and I have b, which is, and this is an x here. I have negative 3x plus 3y minus 2z is equal to negative 8. And if I add these two, I get negative 9x. The y's cancel. I have negative 11z is equal to negative 17. Okay, and then it's your preference, what, you know, because they're all opposite signs right now. My third step would be I would multiply this equation by 9 and this equation by 7. Okay, so I would have 63x plus 72z is equal to 144. When I multiply this one, I have negative 63x minus 77z is equal to negative 119. When I add these, the x's cancel, and I have negative 5z is equal to negative positive 25. I divide by negative 5, divide by negative 5, and z is equal to negative 5. Okay, so that's one of our answers. So we found one of them. Now I could put it in either to this one or this one, and I can solve for x. So let's do that. So I'm going to use the 7x plus 8z. So I have 7x, this is the fourth step, 7x plus 8 times negative 5, which is z, is equal to 16. 7x minus 40 is equal to 16. I'm going to add 40 to both sides. I get 7x is equal to 56. I'm going to divide by 7. And I have x is equal to 8. All right, so I have two variables. Now I have to go back to one of the original ones. Okay, and I went back to A. So step 5, I'm going to use equation A. And I'm going to put in, this is 2 times 8 plus y plus 3 times negative 5, which is z, is equal to 3. And this becomes 16 plus y minus 15 is equal to 3. So if I add 16 and subtract 15 from it, I get y plus 1 is equal to 3. And then I subtract 1, and I get y is equal to 2. So we have x is equal to 8, y is equal to 2, and z is equal to negative 5. All right, on to the next sheet. Dun, dun, dun. 2 more to go. Here we go. All right, so this is the third review I handed out. That was the one paper. I think third period, you got it stapled, and 8th period, you had it as an extra sheet. So we're back to this original function, and I changed this. I said to the nearest hundredth. Really, this should be to the nearest hundredth. All right, so we could set up the two equations with the 2 points that we have. So remember, the general form is y is equal to ab raised to the x power. So using 3, 6, I have 6 is equal to a b raised to the 3rd power. When I use 7, 18, I get 18 is equal to a b raised to the 7th power, and then I'm going to divide both of these. 6 divided by 18 becomes 1/3. The a's will cancel, become 1, and b will be to the 3 minus 7. Right, this becomes b to the 3 minus 7, which is negative 4. All right, now we're going to multiply by this reciprocal. So negative 4, the reciprocal of negative 4 is negative 1/4. And this is negative 1/4. So b ends up being, as a fraction, 1.32. Okay, so that's the first step. Second step, we can take either point and plug it in for x and y, and we can solve for a, because now we know what b is. So I use 3, 6, so I have 6 is equal to a, which we're looking for. B is 1.32, right, raised to the third power. So if you're putting it in your calculator, you know, you can divide both sides by 1.32 raised to the third. Divide this by 1.32 raised to the third. So before you go to your calculator, you can write this, and you put in your calculator 6 divided by 1.32 raised to the third power. And if you do that, you should get a is equal to 2.61. Okay, so now we have our equation is y is equal to 2.61 times b, which is 1.32 raised to the x power. Okay, so that's our equation. So that's one thing we needed. That's one part of the answer. And the other part is to evaluate for x equal to 20. So then we can say f of 20 is equal to 2.61 times 1.32 raised to the 20th power. And if you put that in your calculator, you'll get f of 20 is equal to 673.16. That's the second part. All right. And finally, a parabola. I really hope everybody can do all this in the parabola and get full credit, because this is one of the second parts that are worth the most. The x-intercepts happen when y is equal to 0. All right, so 0 is equal to x squared minus 3x minus 18. So we have to factor. So to factor this into two binomials, we have an x. One sign is going to be negative, and one sign is going to be positive. The factors of 18 are negative 6 and positive 3, right? Negative 6 times 3 is negative 18, and negative 6 plus 3 is negative 3. Oh no, my voice just sounded like the chipmunks, I think. All right. So to make this equal to 0, 1x would be equal to 6, and the other one, x, would be equal to negative 3. Okay? So those were where the zeros are. The zeros would happen at 6 and negative 3. The axis of symmetry, I mean, we always say negative b over 2a, but really the formal formula is x is equal to negative b over 2a. And this represents two things. Number one, the axis of symmetry. And number two, the x-coordinate for the turning point. It's both of those. All right, because it's symmetrical about that point. So the turning point is where it's symmetrical about. So for this equation, b is equal to negative 3, and a is equal to 1. So x is equal to negative 3 over 2 times 1, which is equal to 3 over 2. Okay, so we have the x-coordinate. Now we want to find the y-coordinate. I know a lot of you, so we have to plug it into y equals x squared minus 3x minus 18. And it's easier in your calculator if you just change this to 1.5. Okay? Because if you do a table, you know, you're going to have it, it's between 2 points, and you'd have to figure out where it is. So that's why they do it. So y is equal to let's plug this in. 1.5 squared minus 3 times 1.5 minus 18. If we put all that in, we get y is equal to negative 20.25. So the turning point as a coordinate is 1.5 or 3/2. I'll leave it as a decimal. 1.5 comma negative 20.25. That's the turning point. All right, so I hope you'll help. Good luck on all your exams and have a great day. Monday after your exams, if you're up to it, I'll hang around if you have any questions, and I'll post this on Google. Have a great rest of your weekend. Bye.